Okay, start giving your attendance in the chat box. I'll wait for 2-3 minutes so that all of you can join, and then I'll start teaching. Please write your names in the chat box. Gopika, good. Anyone else who has joined? Shani is there. Okay. Anyone else? Okay, Anurag, Nihar, good. So, guys, what do you, as this is revision class, what do you want me to do? Do you want me to do theorems only, or do you want me to do questions? Or do you want me to mix everything? Just let me know. Yeah, circles only. Oh, okay, both. So fine. I'm starting with theorems first, and I'm starting from very beginning. If required, I'll take 2 classes of circles. Doesn't matter. So I'm starting with theorems. So I'm doing circles only. Okay, let me write here so that I'm going to do circles only. I'm waiting for 2 more minutes. I don't want any one of you to miss this class because we have already done one revision. Still there was problem. I'm doing this. Can you guys check with others whether they are joining or not? I have only four people now till now. Anurag, can you check with Kartikeya? Nihar, can you check with Nishant? Okay, no issues. Okay, so then I'm starting the class. Now, so I'm going theorem by theorem. Mm, Theorem 1 is, and it's about congruency of circles. So what does it tell? Congruency of circles. So it tells that two circles are congruent if and only if they have equal radius. Okay, Anurag, I have started the class. So two circles are congruent if and only if they have equal radius. So suppose I have this circle, I name it C1, and this another circle, I name it C2, and the radius is R1 and radius is R2 here. If I am saying that circle C1 is congruent to circle C2, it tells me that this is only possible when R1 is equal to R2. So this is not a theorem, I'll call it, this is an axiom, because if radius is equal, circle would be overlapping on each other. Hence, I mean, if radius of two circles are equal, then the two circles would be congruent. Now let me go to theorem 2, and theorem 2 to nearly theorem 8 or 9, nearly theorem 9. So theorem 2 to theorem 9 would be theorems about chords of circles. So theorem 2 is equal chords subtend equal angle on the center of the circle or at the center, and vice versa is if angle subtended by two chords, so this is theorem 2 and 3, I'm proving it simultaneously. If angle subtended by two chords at center are equal, chords would be equal. So suppose this is a chord AB and this is my center O and this is chord CD. This doesn't look like same, but I will do this construction. So I have two triangles, triangle AOB and triangle COD. So in first case, what will happen is for theorem 2, I'll wipe it out and prove theorem 3. For theorem 2, AB is equal to CD, it has been given to me, and OA is equal to OD, and OB is equal to OC. These two are radius. So hence side congruency is there, and at side congruency is there by CPCT. Angle opposite to AB, angle opposite. So AB is equal to CD. So angle opposite to equal sides would be equal. Opposite to AB, angle AOB is there, and opposite to CD, angle COD is there. So angle AOB is equal to angle COD. Now what happens in case you have to prove the other theorem, theorem 3, that if angle subtended is equal, so there AOB is equal to angle COD would be given. And I know that OA is equal to OD and OB is equal to OC. This doesn't need to be proved. This is radius. So now this is side angle side congruency. So by CPCT, what I can write is opposite to equal angle sides would be equal. So AB is equal to CD. So in one case you have side congruency. In other case you have side angle side congruency. So these were theorems 2 and 3. If at any point you guys are not understanding any question or any theorem, please write it down in the chat box. Now theorem 2 and theorem 3 I have already proved. Theorem 4 is actually the same thing. It is saying that if two arcs of a circle are congruent, then the corresponding chords are equal. So what I do is I take this circle and I have chord AB here and I have chord CD here. Let me mark it. This is AB and this is CD and this is my center O. Now I am saying you that chord AB and arc AB is equal to arc CD. Congruent to chord CD. So what does it mean? So there are three cases. So case 1 is that AB and CD are, arc AB and CD are minor arcs. So if AB and CD are minor arcs, let me do this construction. So congruency tells me that if two arcs are congruent, this is axiom. If two arcs are, or you can write theorem because in your book it has been given as theorem. If two arcs are congruent, they subtend same angle on the center. So now angle, if they are minor arc, so I'll write that OA is equal to OD, OB is equal to OC. So these are my radius. The two triangles you already know, they are OAB and OCD. And as I'll write angle AOB is equal to angle COD. And here in description, I'll write that arc, minor arc AB is equal to or congruent to minor arc CD, and hence I'll write here, hence angles would be equal. So now you have shown that these angles are equal, so side opposite to equal angles would be equal. Then you can write AB is equal to CD. If you now in case of major arc, if I, in case of minor, I write major, so I have to write like this, that if minor arc AB is congruent to CD, hence major arc, so AB is minor arc, so I'll write BA, major arc BA would also be congruent to major arc DC. And once you write it, the angle again becomes same. So if this angle you assume to be theta, the other angle would be 360 minus theta. So if this is 360 minus theta, this is theta. So you can prove by same method that this would be similar. This would be same, hence the chords would be same. So there is no other method. You just have to one line that if minor arcs AB and CD are same, major arcs BA and DC would also be same. So in that case, the two chords would be same. So I have done it for both major and minor arc. There is very little difference. In minor arc, you can directly write that the angles are same. In major arc, you have to first show that the minor arc is same, and then you have to write that the major arc is same. Now, theorem 5 is exactly the opposite of it. And which says that if chords equal, I'm not writing the complete theorem because it is taking a lot of time. If chords equal, then arcs are same. Arcs are congruent. So you don't have to do anything. I have already told you that if AB is one chord and CD is another chord, and I do this construction, center is O, I have in triangle OAB and triangle OCD, I have AB is equal to CD, it has been given to me, and OA is equal to OD and OB is equal to OC because they are radius. So side congruency, and hence by CPCT you have angle AOB equal to angle COD. And when these two angles are equal, so if angles are equal, I can write that minor arc AB is equal to minor arc CD. And once you write this, you can say that AB is congruent to CD. Now, if AB is congruent to CD, so this is for minor arc. For major arc, what we need to do is that we need to write that that as AB is equal to CD, so BA would be equal to DC. You just need to add, and this major arc would be equal. Now you need to write that if this angle is theta, the other angle would be 360 minus theta. Here also it is 360 minus theta. It shows that these major arcs are same. Now if this is making angle theta, these two arcs would make angle theta, and you need to write that major arc BA would be congruent to major arc DC. And once you write that, you can write that the chords are equal, or if chords are equal, this possibility is there. In case of semicircle, you can write that the two arcs are same, they are making 180-degree angle. So hence the two chords would be semicircles. Two semicircles of a circle are congruent to each other. Now another type of all these were from theorem 2 to theorem 5 were all same. What, Anurag, which question you are asking? BD and AC? I am not saying BD and AC are same. So next theorem is, okay, you can ask me ask that question to me later. Individually, I'll clarify it. I am going to theorem 6, and theorem 6 tells me that the perpendicular drawn from the center of the circle bisects the circle. So perpendicular to chord bisects it. To chord from center, I'm writing here, not from any other point. From center bisects it. So how do I do it? I know that I will suppose this is O, this is A, this is B, and this is C. So I have two triangles OCA and triangles OCB. And what I'll do is I'll write that OA is equal to OB, OC and OC is common, and angle OCA is equal to angle OCB is equal to 90-degree. It has been given to me. This is common and this is radius. Hence, I have RHS congruency. And as I have RHS congruency, so side opposite to angle opposite to equal sides would be equal. So opposite to OA, the angle is OCA, and opposite to OB, it is angle OCB. So angle OCA is equal to OCB. I also know that angle OCA plus angle OCB is equal to 180-degree. And as they two are equal, suppose they are equal to x, so 2x is equal to 180, x is equal to 90 degrees. So I can write that this angle is 90-degree, and this is how I prove it. Now, converse of this theorem tells me that the line drawn through the center of a circle to bisect the chord is perpendicular. So in converse of this theorem, what happens is, I have been given that here one thing was left out is that I have to prove that it bisects this. So this angle and this angle, because what happens is in what I proved was AC is equal to BC and opposite to or you can write that this angle is equal to this angle. So angle AOC is equal to angle BOC, and if that is true, then AC becomes equal to BC. So you can say that this has been, and converse of this theorem would be that you have to prove that it is perpendicular. So you will be given that this bisects this. So if from center I draw a line, the theorem is, this is the center of the circle, this is chord AB, I am drawing a line which is bisecting the chord. So I'm doing this construction OA and OB. So I write that OA is equal to OB. I have been given that AC is equal to BC. This has been given to me. And then I know that OC is equal to OC. So side congruency. Hence, this angle would be equal to this angle. And by adding it, you can prove that this is 90 degree, which I just did. So these two theorems get proved easily. Now, let me tell you I have to prove that there is a corollary which needs to be proved, and this is very important. So look at it. The perpendicular bisectors, the perpendicular of two chords of a circle intersect at its center. So what I have to do is, I am drawing this circle, and this is one of my chord, and this is second of my chord. I give its name AB and CD, and I have a perpendicular bisector. So suppose this is E and this is point O, and I have another perpendicular bisector which is OF, and suppose instead of O, these perpendicular bisectors meet at O dash. So why I am drawing O dash, I am explaining here. I am drawing O dash so that I can prove that O and O dash coincide. If I'm able to prove that O and O dash coincide, in that situation, what happens that I'll be able to prove that any other point other than O taken as the point of intersection of perpendicular bisectors of two chords would meet at O only. Any other point, if I take and that point coincides with O, that will prove my theorem. So I have to prove here that O dash coincides with O. So for that I have matched OE and OF. Now it has been given that they are perpendicular bisectors. So proof is E is midpoint of AB. Now I just told you that if E is midpoint of AB and OE is perpendicular to AB and O dash E also is perpendicular to EB. I have taken 2 points, O and O dash. This is only possible, this O dash E, this is only possible when O dash E lies along OE. Similarly, I can write that OF is perpendicular to CD and O dash F also is perpendicular to CD, and this is only possible when O dash F lies along CD. So, sorry, OF. So, what happens is I have proved that O dash E lies along OE and O dash F. Okay, so Anurag, what I'm trying to do is in this corollary is, it has been asked to me to prove that whatever perpendicular bisectors we draw on chord passes through center. So the idea behind this theorem is that I have to prove that all the perpendicular bisectors of any chord will pass through center. How will I prove that any perpendicular bisector will pass through center? So for that, what I am doing, instead of center, I am taking any other point O dash and I am joining O dash with the midpoint of the chord. So I have joined O dash with E, I have joined O dash with F, and I have center O. So I have joined OE also and OF also. From the previous theorems which I have proved, I know that the perpendicular bisector OE has to pass through center. So I am writing that OE is perpendicular to AB. But what I have done is I have taken any other point O dash in the circle, and I'm saying that O dash E is also perpendicular to AB. Why O dash E is perpendicular to AB? Because I have assumed that O dash is such a point that O dash E is perpendicular to AB. So this I am writing by previous theorems. So this is on the basis of previous theorems which I just proved, and this I have assumed that any other point O dash is taken, and this I have assumed. So both these cases will not be possible. This will only be possible when O dash E and OE would be a same line. So that is why I have written that O dash E lies along OE, and similarly for other case also. Now did you understand? Did you understand, Anurag? Anurag, are you there? Okay, fine. Anurag perhaps is not here. So O dash E and O dash F lies along OE and OF respectively. So it means that intersection of point or of intersection of O dash E and O dash F would be O dash, and O dash coincides with O. So that's how you need to prove it. Now let me move to another theorem, which is now theorem 8 tells me that equal chords are equidistant from each other. So I draw a circle like this, and I have a chord AB, I have another chord CD. Now, distance of, please understand this, distance of, suppose this is point O, distance of O from any line, or distance of any line from a point is always taken as a perpendicular drawn from that point to that line. So if I have a point here and I have a line here, I will not take this distance as distance from, suppose this is AB and this is C. So distance between C and AB is not this distance. Distance between AB and C is this perpendicular distance. So CD is distance between point C and line AB. Now here I will match these two. So what happens is I have to prove that I draw a perpendicular here. I have to prove that this is not D, suppose this is M and this is N. So I have to prove that OM is equal to ON. So I have been given AB is equal to CD, and I know that, or what I do is I take these two triangles. So I take triangle OAN and triangle OCM. These two triangles, triangle 1 and triangle 2, I'm taking. So here I have been given that I know that in this triangle OA is equal to OC because this is radius R, and I know half of AB because AB is equal to CD, so half of AB would be equal to half of CD, and half of AB is equal to half of CD, which says me that AN is equal to CM, and I know that this is 90 degree as I'm drawing perpendicular from here, so that would be nothing but angle ONA is equal to angle OMC, which is equal to 90 degree. So it means that triangle OMC and triangle ONA are congruent to each other. If they are congruent to each other, it means that these two angles are equal, or by CPCT you can write that OM is equal to ON. So AB and CD are distant from O. Now opposite of it, so it has been saying that chords which are equidistant from, there are too many theorems in the beginning, there are 18 theorems, so it will take some time for me to finish off these theorems. So chords Nihal, just give me 10 minutes, I'll start solving questions. Chords equidistant from each other not each other, sorry, equidistance from center are equal. So suppose this is AB and this is CD. So this is a perpendicular drawn. This is a perpendicular drawn. Is O. So what happens here is I need to prove that, and this is suppose M and this is N. So I need to prove that AB is equal to CD. This is to prove. Now how do I prove it? So let's take triangle. I know that AM is equal to half of AB, and CN is equal to half of CD. So if I'm able to prove that AM is equal to CN, then I'm able to prove that AB is equal to CD. So let me write here. I'm taking triangles OMA and triangles ONC. So OA is equal to OC, and I have been given that OM is equal to ON because they are equidistant, and angle OMA is equal to angle ONC, which is 90 degree. Hence these two triangles are congruent, and once they are congruent you can show that AM is equal to CN. You multiply 2 to 8, you will write AB is equal to CD. Now what I'm doing is I'm on the basis of this theorem is only, which is there in your book. You solve two theorems, you will understand it completely. That one theorem is uh, of any two chords which is nearer to center, the one which is of any two chords, the one which is nearer to center will be longer, and one which is farther from center would be smaller. So you can take this theorem, you can look in the book and opposite of this. So now I'm taking a few questions on the basis. There are few theorems for congruency of two theorems. There is nothing in that. Just go through from congruency of two circles. Just go through the theorems in your book. You will understand everything. Congruency of two circles. You will understand everything. Every time you will have to prove that the radius is equal, and obvious things would be given there. So these were few important theorems which I took. Now let me solve a few questions for you. The first question which I'm taking is, write down this question. Two chords AB and AC of a circle are equal. Prove that the center of the circle lies on the angular bisector of angle BSC. Just solve this question. I give you 2-3 minutes to solve this question. And let me know when you are done with the question. Hello. Yes, who's this? हाँ आनंद. हम फोन करता नहीं, रोहित बोलता नहीं. फोन करता नहीं. आधा घंटा 40 मिनट. Okay, Ishani has done it. Obviously, you have to do the construction, Anurag. Without construction, how will you solve it? I'm waiting for others. Okay, Nishant got it. 2 more minutes. Okay, so all of you got it. Anurag, I'm just waiting for you. If you're not getting it, just let me know. Okay, so as Gopika is telling me to explain, I'll explain it. So how to do this question? It's like this. So what we need to do over here is there are two chords AB and AC. So this is my circle. And this is AB, and this is, let me make another chord. This is AC, and this is point O. So, and this is any point. So this is point O, and this is D. Let me match this, and let me call it M. So suppose AD is bisector of angle BAC. AD, one second. So suppose AD is bisector of angle AD is bisector of angle BAC. So what happens is I have to prove that OA lies on AD. This I have to prove that OA lies on AD. So for that, what I'm doing is I'm constructing a line where I'm drawing BC. Now I take triangle BAM and triangle CAM. So I take these two triangles. I know that AB is equal to AC because it has been given to me like this. Angle BAM is equal to angle CAM because they angular bisector, as AO is angular bisector. So angular bisector will divide the angles equally. So hence these two angles are equal. And here AM is equal to AM. So I have side angle side congruency, and in side angle side congruency I have BM is equal to CM, and I also know that these two angles would also be equal because these two angles are opposite equal side BA. So BA and AB and AC. So I know that BMA is equal to angle CMA, and I know that angle BMA plus angle CMA is equal to 180-degree. Hence they both would be equal to 90-degree. It says that AM is perpendicular bisector of AM is perpendicular bisector of BC. And if it is perpendicular bisector of BC, so you try to understand after this it's only about writing adequate things. And how do you write it? So you write that AM is part of AD. So it means that AD is perpendicular to BC, or perpendicular bisector to BC of BC. And if AD is perpendicular bisector of BC, I know that all the perpendicular bisector, I just proved the corollary. I wrote that all the perpendicular bisectors of a chord will pass through center. So it means that OM has to be part of AD. And if OM has to be part of AD, it means that O lies on AD. So that's how you have to prove this. Any doubt now? Okay. Now let me give you another good quality questions. So the question is, if two circles intersect in 2 points, prove that the line through their centers is perpendicular bisector of the common chord. Just prove it. Anurag, if you have done it differently, the previous question, just show it to me in the class. I'll check whether it is correct or not. Okay, Ishani got it. Have you done? How many of you have done? Only Gopika and Ishani has done. Okay, let me solve it. Enough time. Nihar got it. 1 second. I started looking. This is one circle and this is another circle. So what happens here is this is a line, this is O, this is O dash, and I draw a line from O to O dash, and then I draw a line here, this is A, and this is B, and this is radius R, and this is radius S. So I have to prove that O dash is perpendicular to AB. This is what I have to prove. And if this is what I have to prove, the best way to prove is to prove that angle OA. So suppose this point is M. So angle OMA is equal to angle OMB. If I'm able to prove it, I know that addition of OMA and OMB is 180 degree and both are equal. So hence that would be 90 degree. So what I do is I take triangle OAO dash and triangle OBO dash, and I'll prove that they are congruent. So what I do is I write OA is equal to OB here. I write O dash S is O dash A is equal to O dash B. This is radius R. This is radius S, and OO dash is common to both of them. So this is common. So hence side congruence is there. And if side congruence is there, then I can write down two things. So which is this, that this total angle O AO dash is equal to angle OBO dash. This is equal by CPCT. I can also write that angle angle AO dash is equal to angle BO dash. This also I can write. So what happens is, now look at here. Now this side is and I can also write that AO dash I have written. So it means that this angle is equal to this angle. And if this angle is equal to this angle, then I can write that angle AOS AOM, which I have already written here, that angle AOO dash. So I can write here angle AOM is equal to angle BOM. So this is nothing but this only, just instead of O dash, and M falls on O dash. So what I can do is I can write from here that now let me take triangle OAM and triangle OBM, and in this triangle I know that OA is equal to OS. I also know that OM is common to both of them, and I have already proven that angle AOM is equal to angle BOM. So I have side angle side congruency, and from that I can prove that angle by CPCT I can write here, I'm writing here by CPCT I can write here that angle OMA is equal to angle OMB, and they both are equal, and their addition I have already told you here that their addition would be equal to 180. So you can write that this is equal to 90 degree. As simple. Now let me give you another question. And the question is, write down the question. I'm orating the question, write down the question. Let's not waste the time. I'll write it. Prove that the perpendicular bisector of the chord. Prove that the perpendicular bisector of the chord of a circle always passes through center. Okay, leave this question. We have already done this. I thought this is a different question. 1 second. This perhaps I have done in the, leave that question which I was trying to give you. This perhaps I have already solved in the, so I have two chords AB and CD. AB is equal to CD and center is O and radius is R. So what happens here is these two chords intersect at E, and from O I draw perpendiculars. So this is 90 degrees. Suppose this is M, this is N, this is also 90 degree. So you have to prove that OMEN is a square. Yes, AB is equal to CD. I have written. O is the center of the circle and AB is equal to CD. Okay, so one person has got it. Gopika got it. I'm waiting for others. Anyone who is not getting the answer? Nishant got it. Ishani got it. I'm waiting for Anurag and Nihar. I think Kartikeya has left. Okay, so let me solve it for you guys. One more question, and then I'll wrap up. So the question, this question can be solved like this. So uh, join this OE so that you can form two circles, and I know that if these are midpoints, so I've already given you this is perpendicular. So you know that OM is equal to ON and OE is equal to OE, and angle OME is equal to angle ONE. So by RHS congruency, sorry, not RHS, what is this? You can also write that yes, RHS only. What's more? RHS congruency, you can write that ME is equal to EN. I already know that. Try to understand. I already know that OM is equal to ON because the chords are equal, hence perpendicular bisectors on it would be equal. So all four sides I have shown equal. Now I need to show that this is already 90 degree. So this and this is already 90 degree. So two angles are 90 degree. What about other two angles, this and this? So this Doesn't need to be proved. You can write that if these two angles are 90 degree, OMEN would be a square. So that's how you get answer of this question. I'm giving a next question, which is show that if two chords of a circle bisect each other, they must be diameters of the circle. Solve it. Let me know when you guys are done. Nishant got it. Anyone else? Ishani got it. Okay, 1 more minute, then I'll solve. Okay, let me solve it. So suppose I have a circle. Once again, let me make a good circle. My drawing is very bad. I have a circle like this, and I have chord AB, and I have chord CD. So what it is here is this is O, and they are intersecting at point O, and they are bisecting each other. It has been given. So I'll have to take OB is equal to OA is equal to OB, and OC is equal to OD. That has been given to me. Now to prove this, I'll join all these points. So what I do over here is that I take triangle AOC and triangle opposite triangle BOD, and what I get over here is that OA is equal to OB and OC is equal to OD, and angle AOC is equal to angle BOD. Why? Because this is vertically opposite angle. So it means that triangle AOC is congruent with triangle BOD, and in this particular case, AC is equal to BD. Similarly, I can take triangle AOD and triangle BOC, and I can write that OA is equal to uh, triangle AOD and BOC. So what I can take here is, so AO is equal to OB and OC is equal to OD, and I can also write that angle AOD is equal to angle BOC. So this is vertically opposite angle. So I can write that AD is equal to BC. But what do I get by writing this? So as soon as I write this, I also know that uh, uh, this minor segment AC is equal to BD, and here I get segment AD is equal to segment BC. So what I get is, I can add these two. I know AC plus AD is equal to BC plus BD. Now, suppose this total is X and this total is X. So AC plus AD plus BC plus BD is complete circle. So it's circumference of the circle. So it means that this is semicircle and this is semicircle. So if these two are semicircle, so it tells me that AC plus AD is nothing but, you can write CAD is a semicircle equal to the other part of semicircle, which is CBD. And if these two are semicircle, then you can write that CD is diameter. And similarly, you can write that from this side AC plus BC, you can write it, and AD plus BD you can write, and you can show that AC is a diameter. So that's how you can show that these two are diameter to each other. So now what I'll say is that these two are diameter. So I'm wrapping up the class now because it's time. On Wednesday, I'll give you an envelope test, which will be based on quadrilaterals and circles, as I have announced in the class. So I would like all of you to just focus on that test and get good marks in that test. You should submit the test in Friday's class. So be ready for the test. So thank you so much for joining the class. See you on Wednesday. Thank you. Bye bye.